Let's discuss another important term regarding SHM as its representation. For majority of problems, we need to analyze the SHM representation by which we can handle different kind of problems. The important thing about representation, we should always treat that every SHM can be represented by motion of projection of a particle in uniform circular motion on diameter of its circle. If say a particle is executing uniform circular motion in a circular path, like say if I draw a circle and say a particle is following the circular motion and say at t equal to 0 particle was located here and it started revolving at an angular speed omega. We know that in uniform circular motion omega is a constant. If it is moving, let's consider projection of this particle on its vertical diameter y dash. So initially when it was located here, its projection was at this point. When it moves and reaches a position like this, its projection will travel from this position to this position. Now you can imagine if the particle is moving in the circular path, the projection will be first going up, then returns, then come down, then moves up. So in this motion we can state the particle will be executing oscillations. If in these oscillations the required condition for SHM is satisfied, then we can treat the motion of this motion of projection as SHM, or this motion we use to represent all kind of SHMs. Let's analyze. Say if the radius of this circle is r, then we can state for the oscillation of this projection, r will be the amplitude of motion because r is the maximum displacement of projection from its mean position. Now in this situation at t equal to 0, say if it was started from this point, and at a general time t, it will revolve by an angle omega t. So in this situation, the displacement of this projection, say if it is y, this y can be simply written as, say if the particle is p and its projection is p dash, then at time t we can state at time t equals to t, projection p dash is at a displacement y, which can be given as r sine of omega t. Now in this situation, as this is omega t, this is also omega t, here we can write simply by this right angle triangle, y is r sine omega t. So in this situation we can state y depends on time, and we find out the velocity of particle. Velocity can be calculated directly as dy by dt. If we differentiate the expression with respect to time, this will give us r omega cos of omega t. And if we find out acceleration of particle, this dv by dt, which can be given as, if we once again differentiate it, this will give us minus r omega square sine omega t. And here you can see this r sine omega t can be written as y. So we can write the acceleration to be minus omega square y. So here you can see in this particular kind of motion, acceleration is directly proportional to minus y. That means the particle, the projection, if it is representing a particle, then this oscillation can be regarded as SHM because at every instant when it is at a displacement y from mean position, its acceleration can be given as a direct proportional function of y and is directly acting towards the center. So always remember that any SHM can be represented by the projection of a uniform circular motion on its diameter.